All right, guys. So starting chapter 9, we're talking about just point estimation. So we're not going into confidence intervals just yet. We're going to talk about what a point estimation is. All right, this is kind of like just the intro into what confidence intervals do. All right, so just laying it out there right up front, what is a point estimate? It's a single number, a statistic, right, based off of sample data used to estimate a population parameter. All right. So the reason why it's called a point estimate is because it's just a single point, like on a number line. Like, let's say this is the population characteristic we're looking for. Like, let's say population mean, right? So we're trying to estimate the population mean. We get a sample, and then we evaluate, and then we get this 1 point from this one sample. Okay. Notice it is not always equal to the population characteristic due to sampling variability. Okay. So, like, for example, let's say I, wanted to get the population head size of all the girl seniors at San Marino High School. All right. So head size, there is a true average, but let's say I take a random sample of like 5 of you guys here, right? And I measure your heads. Your average, your sample average might not be exactly at the population average. It might differ a little bit, right? And that's just natural, like sampling variability, right? Because each sample is just a little bit different. All right, so this is actually going to be super intuitive. Okay, so I want to try something before I try our example here on the notes. So open up the chat box. And I want you guys to tell me if I wanted to estimate the population mean, right? So let's say the true average head size of all the senior girls at San Marino High School. If I wanted to estimate what that is, but because of, COVID, I couldn't go and actually get the head sizes of every single senior girl at San Marino High School. So instead, I take a random sample of seniors in my class and I ask them their head size, right? And I get a list of like 5. I get 5 head sizes. What should I do with those 5 head sizes in order to estimate the population average? What would you calculate from your sample? What do you guys think? Put it in the chat. What would you do with those 5 head sizes to estimate the population mean? Nice, guys. Yeah, good. Nice, Clancy. Good. That's exactly it. So yeah, I was hoping, I was like, I think it's intuitive, but I wasn't sure, but you guys are definitely telling me that it is. It is very intuitive. Yeah, every single one of you guys. So in order to find the population mean, you would find the sample mean to estimate the population mean, right? Like that, I hope that that just makes sense, okay? So that really is what our lesson is gonna be. I don't want you guys to overcomplicate it, okay? It's really intuitive. Okay, so let's try this one. Let me get a reader and we'll try to find some point estimates. All right, so we're going to try to find some point estimates. Let's see. Kira, can you read this one out for us, please?
Yeah. The paper reports the results of 7,421 students at 40 colleges and universities. The authors want to estimate the proportion of college students who spend more than 3 hours a day on the internet.
Well, keep going.
Do you want me to keep going? Or
yeah, go ahead and keep going.
okay. 2,998 out of 7,421 students report using the internet more than 3 hours a day.
Perfect. Thank you, Kara. All right, so we want to estimate the proportion, the true population proportion of college students who spend more than 3 hours a day on the internet. We get a sample and we get these values. All right, so what would be our point estimate for the population proportion? In the chat, tell me what you guys would do. What would you do with those numbers? Yeah, so exactly what you guys were thinking, you would find the proportion. Yeah, you would find the proportion of the sample to estimate the proportion of the population. Okay? So to do that, the sample proportion, that's why there's a hat on it, 2,998 divided by 7,421 gets you 404. And this is your point estimate. All right, the sample proportion to estimate the population proportion, just like the sample mean would be a point estimate of the population mean. Okay, so see how that goes? All right, good. So this is our point estimate. Nice. Okay, let's try another one. Let's go. Clancy, can you read this one out for us, please?
The paper, The Impact of Internet and Television Use on the Reading Habits and Practices of College Students. Oh, sorry, should I not have read that part?
Oh, no, you're good.
So, Journal of Adolescence and Adult Literacy investigates the reading habits of college students. The following observations represent the number of hours spent on academic reading in 1 week by 20 college students.
Awesome. All right, thank you. So these are, this is our sample, right? This is our sample of 20 college students. This is the dot plot of it, just to kind of see what the sample distribution would look like. And if I want to find the point estimate of the population mean, what do you think I'm going to do with this sample? Go ahead and put it in the chat. If I want to find the population mean, what do you think I'm going to do with this sample? You don't actually have to do it right now. Just in general, what would you do? Good. Yep. Nice, Clancy. All right, guys. So yeah, you average them. Okay. So I'm just trying to show you guys just to embrace the intuitiveness of it. Don't overcomplicate it. Okay. You just find the average. Find the average of your sample. That will be your point estimate for the population mean. Good. What if I want to find the standard deviation, right? What if I want to find the standard deviation of the population? What should I do with the sample? Well, I would find the sample standard deviation, right? So, like I said, intuitive. Cool. All right, so just to kind of give you a little insight into the thought process of why, okay, or what makes a good point estimate. The first thing we want to do is to choose a statistic that is unbiased. And unbiased just means accurate. It's accurate. Okay. So a statistic whose mean value is equal to the population, right, is said to be unbiased. Okay. So for example, like let's say the true value, this represents the population, let's say mean, for example. All right. If the true value is the population mean, and these are different statistics we've used, right? The orange one would be considered biased, right? Because the center of this graph is not centered at the true value. So this would not be a good statistic to use as a point estimate. The blue one and the teal one, these are unbiased because they're centered at that true value, okay? Now, the other thing is that we want something that's very consistently at the true value, right? We want to choose one with the smallest standard deviation. So even though these two are unbiased, this one in blue on the left is not as precise as this one. So if I had to pick out of those three statistics which one to use, I would choose the very right one because it's centered at the true value and it's most consistent. And I'm telling you guys this because if you were to, let's say, not have the intuition of let's use the sample mean to estimate the population mean, and you used a lot of different things, and that's what people did, right? People experimented and tried out different ways to estimate the population mean. It turns out that the sample mean is the best because it is unbiased and it had the smallest standard deviation. Okay? All right, so that's what this bubble is. If the population distribution is normal, then your sample mean has a smaller standard deviation than any other unbiased statistic for estimating the population mean. All right, any questions? All right, the last thing is I do want you guys to watch this AP Stats Guy video. And what is a confidence interval? Will intro us into what the rest of the chapter is about. Okay? So let me stop this.